let's check the pH of some household items and see how they are related to each other. First of all, let's do with water. So I know water, we all know that it's supposed to be a 7 because it's neutral. Let's see if that is so. So I'm going to take some water into this, and this is the pH paper that I'm going to use. So it is already colored, and then it comes with this nice scale. All we're going to do is dip it into any liquid that we are interested in and then check right away. It does not take any time at all. So I'm just dipping it into water, and then I try to compare here. See that is 7, that's 6, but it's not really 7, not really 6. So normally faucet water is not 7. It's a little bit less than 7. It's kind of towards 6 because the water that comes to our house, it actually comes from ground, and it also comes through lots of metal pipes all through. So it might end up dissolving other stuff. Which is not bad. Actually, we shouldn't be drinking water that is 7 because that has nothing useful in us, like in it, like basically no minerals, nothing, no dissolved substances. It's absolutely all right to drink water at pH 6 as long as it is does not contain any other microbes and all that. Next one, let's check milk. Okay, so milk is, just before we check, like make a guess. Milk is, what would it be? Is it like water? Is it worse than water? Or, which way would it go? One kind of hint to think of is every food item that most of the food items that we eat and drink and all, they are all acidic. So let's see where does milk stand. So I'll take a little bit of milk and then again just dip it, and I can see where it goes again, kind of if I'm doing this. It's again, do you see, it's a little bit like less than 7. Milk is normally, if you compare the second, third and 4 squares in there, milk is a little bit 6, but as milk is normally a little bit above 6. It's about like 6.4 or so. That's why milk is actually mildly acidic. So sometimes when we have a stomach upset, stomach flu and all that, we might hear doctors tell us not to drink milk because even this little acidity can actually upset the stomach. But buttermilk, which can also be about the same pH, but buttermilk can actually good for the digestion because it contains bacteria that's actually friendly, that can actually settle the stomach. So let's check now what's the pH of, like, say, coffee. What I have here is coffee powder. We cannot check pH of solids because, how do we dip the pH paper into this? So what we're going to take is take a little bit of coffee powder here, and then add some water to that to make it into a liquid, because we already know the water pH. If we know the water pH, we can kind of figure out like what's the difference. Coffee actually stains the pH papers a little bit, so it's in a way it's kind of hard to check, but let's see. Okay, so if I do that, like, can you guys see coffee it's actually matching around 5. Okay, coffee is about a pH of 5. 5 means it's every unit of pH is 10 times worse. So from water to coffee, 7 to 5 is 100 times more acidic. Coffee is 100 times more acidic than water. So that's why, until certain age, normally it's not a good idea to drink caffeinated drinks. Now I have something, some of you may like it, but it's even more, you can make a guess. What do you think? Is it like coffee, worse than coffee? Let's see. So it also contains caffeine. On top of that, it also contains, other chemicals and carbon dioxide and all that. So let's check. So if I just dip it and then check it here. So can you see it's maybe around 4. So, and then depending on the strength, it could also be, sometimes it can also be 5, but it's about 4. 7 to 4 is, like 1,000 times worse. So coke is, compared to water, is 1,000 times more acidic. It is so acidic that sometimes if you have any leftover coke at home and nobody is, going to drink it anyway anymore, so coke can be a very good cleaning liquid. It cleans the toilets and sinks and all with all the all the stains. So you can imagine, like, it's a strong acid and it will take away all the stains. So one time I was doing a class like this, a demonstration class, and I was telling some high school kids the thing, saying, oh, do you see, coke is like 1,000 times worse than water. It's it can actually be used as a cleaning solution. So I meant to say as a discouraging thing, and then the one of the high school kids says as a joke, he says, oh, the reason I drink coke is because I want my insides to be clean. So good try, but no, it does not clean your insides. And then the strongest acid I have to demonstrate today is like lemon juice, lime juice, whichever. One can guess, you all know with experience that lemon juice is more acidic than any of these, because you see, if you ever have like a cut on your skin or something and you touch lemons and oranges and all that, it actually burns because it's so acidic. Normally our skin protects us, but if you have a cut in the skin, this one directly touches the nerve endings and it can be very painful. So let's see, where does the lemon juice stand. So just easier to basically do this, and then see the pH of lemon juice. It is around 2. Okay, from 7 to 2 is actually 5 numbers down. That's like 100,000 times stronger. But do you see, it simply because pH is lower, it does not mean it's dangerous. This is pH 2. If I just told you that I have an acid of pH 2, you would have thought it's something very dangerous, but it's food item. Lemon is food that we drink, eat and all that. So pH is different from how dangerous something is. So these are all acids. Now let's look at something on the basic side. Any soap that we know is basic. Most soaps are basic, but some soaps are worse than the other. So let's look at, say, this is basically a dishwashing soap, and we touch it and all that. So it should not be bad, because if this is like harmful to our skin, we handle this one every day, so that would have been like bad. So to check the color, we are kind of like run out of the color samples here. Let's turn it this way and then try to check this way. It's not really matching anywhere here. No purple. So it's still kind of here. It's kind of like 7, maybe a little bit over 7. This scale only has whole numbers, so if it's decimals, we can't really see, but it's a little bit over 7. That makes sense, because this is not something harmful for us. Now let's do some that are maybe a little bit worse than anything. So this is Chlorox. Chlorox is a bit of bleach. It should be, hopefully it's maybe a little bit like stronger than the other ones. So still it's not 100% bleach, it's just a diluted bleach solution. So let's see how this one looks like. So that's purple, but maybe it'll match something this side. It's like kind of here. Chlorox seems to be around maybe 9, right? Because the last 2 are basically over there. It's between 8 and 9. So really not so bad. Chlorox is over there. Then let's see something that may be more harsh than Chlorox. This is a solution called ammonia. Ammonia is a household cleaner. It smells very, very strong. In fact, it's so strong that, back in the olden times, people used to use this as a, like smelling salts. When somebody fainted, they would make them smell ammonium salts. They are so strong that they would actually bring them out of their faint. So if we see that, do you see it's somewhere maybe, between 12 and 13. So more like 13. That's very, very strong base. So that is over there. So all together, you can see the color variation, how the color changed with each of them. So if I had written down the names, I was not sure of the last 2 where they would fit. So once I have all the names here in the other one, so you can see.